Hello everyone, my name is Pedro Magalhães. In this tutorial, I'll show you how to perform a reverse engineer on the CBDC from Brazil, which will be the first CBDC ERC20 token from the central banks. Recently, I discovered a few controversial functions in the BI provided by the central bank. One of them is the balance freezing function. After discovering this, I shared the news on my social media, and it was also reported by the Open Telegraph News. People started buzzing about it. On Twitter, it was reportedly discussed by many users and became one of the most trading topics in Brazil. But what is Real Digital? Real Digital will be the CBDC from Brazil. Despite being digital, it's important to note that it's not a cryptocurrency. As you can see in this illustration, each node will be delegated from the central bank. And to be a node, you need to be authorized financial company from Brazil. So that's why I said it's not cryptocurrency because all this node will be a private node and also need to be a delegate and authorized from the central bank. So what you'll be learning on this tutorial? First of all, we have an overview about the CBDC project, the Real Digital. After that, we will be analyzing the CBDC source code function and an in-depth exploration of the functionality discovered in the CBDC source code, and also understand features like the account freezing, adjust and balancing. We also gonna examine CBDC and DeFi protocols and look for insights into the intersection of the CBDC and DeFi protocols. We're also going to see a potential use case for interacting CBDC into the DeFi ecosystem and the importance of security transfers in CBDC project. Address and concern benefits is also to looking for address concern from the CBDC community regarding CBDCs. And also we are evaluating benefits such as the traceable taxes and transparent government spending. At the end, we're also going to see the regulatory and public exposure, the importance of regulatory consideration in CBDC development. At the end, we will also show a regulatory and public exposure, the importance of regulatory consideration in CBDC development, the need for public exposure of smart contract specifics in CBDC projects, and the role of transparency in building trust in CBDC. First of all, let's analyze the content of the repository provided from the central bank. So we have here some files that in Portuguese, but I'm going to translate them into English so that you can understand. So what we're going to focus on right now is the ABI folder. So by clicking here on the ABI section, we enter the folder and see various types of ABIs that we have provided. The main ones that you need to work with call it Real Digital. The realdigital.json is a file that will be used for smart contract in the ERC20 standard. But it will be the smart contract between the central bank and the participating financial institutions. In this case, the bank. We're dealing with this structure of the bank here. For example, we use it to divide in two parts. The first one is the Real Digital Varejo, well, retail, and Real Digital Atacado, wholesale. So Real Digital Retail is the structure between the banks and the central bank. It's like money that circulates between central banks and commercial banks. Secondly, we have the real tokenizado or real tokenization. Is the money that we circulate be among the Brazilians, where the government plays in a role in our daily lives. So when we make a transaction between companies or individuals, we have access to this real tokenization, which is the currency that will be used for people's daily lives. So by clicking here on this file, we have access for the structure of the ABI. all this functionality, all these types of function are being configured within the ABI. So what we need to do is index what functions and parameters they are expecting. All right, guys, as you can see, we're going to use this Ethereum ABI to Solidity converter. The main goal of this website is to convert the ABI to a generate interface. So I will just copy the ABI provided from the Real tokenizado and we will paste the ABI right here. Then I will just press the converter to the code button. All right, that's it. We have the interface generated, and we can see a few functions that is included in this smart contract. So as you can see, this functions here is related to the access control. Also, we have some functions related to the ERC token. We have this authorized accounts. We also have this CNPJ8. Well, this is the, let's say, company's identifications. So that's it. We found that weird function, right? Decrease and decrease frozen balance. We also have this disable enable account. We also have the frozen balance off. Uh, yeah, that's why I found that weird function. It was not hard. Okay, now once we have know each function they are working on, now we need to recreate the entire smart contract using the provider packet.json. So as you can see, we can find this packet.json inside this examples folder and packet.json file content. Now we can see all this dependence which we're gonna use to recreate our smart contract. Okay, we have enough information to start to recreate our smart contract. So let's do it. All right, guys, let's continue our uh, smart contract implementation using the ABI provider. But first of all, we need to create a new folder and a hard hat project. So I will open my terminal. Okay, let me just go into my, oh, sorry. Okay, so I will just go into my project folder and I will create a new file. So I will run this comment. I will call it as my CBDC project. Okay, so I'm going to this folder, and now I will just get start my end. So I will just start my project with your init and yes for all. Okay, we have the package.json. Now I will run the yarn add hard hat. Okay, actually I'm doing something better. Let me use the npx hard hat image. Okay. Yeah, just let's go ahead with the JavaScript project. Yeah, yes, and yes. Okay, let's wait. All right, guys, so we need to install all these dampeners and the correct version. So that's why I prepare a note that we can use, and you can also check in the for this tutorial. And yeah, so let's go ahead and I will just copy and paste because it's pretty easy because we have this all this Japanese in correct version. So let's install it. All right. Just in case, guys, I'm using Yarn because I don't know, I prefer to use Yarn to install dependence in the Node applications. All right, cool. It's finished. So let's open the Visual Code. Yeah, I don't know about you guys, but I use it to do this comment. This comment here, like code space and a dot. I can open the visual code in the currently folder. So cool. Yeah, yeah, that's okay. Uh, let's let's clean some files that we don't use, like this script.js and lock.js inside the test. Well, we won't use it now. Cool. So let's rename this file here to CBDC, and we remove all this content here, and also remove this line here. Okay, let's write CBDC. We're also gonna to copy and paste the way they are handled, the hard hat config file. So I'll just copy here and pass into our actual hard hat configuration file. So just copy and paste. Okay, but I will do something different. Sorry, guys, I will do something different. Let me just erase this part here about the network because they prepare this file to be a node from the Hyperledger basis, but we just need to recreate the smart contract, so we're gonna use their blockchain from the hard hat. All right. Okay, we have no head. We don't have this library here. Okay, okay, gotcha. Because they are using TypeScript. You in the our actual project is in JavaScript. So let's do something like easy. Just remove that. Okay. All right. So let's go back to our contract. As you can say, as you remember, guys, we need to import some libraries here because they are using the let's say the opens app contract. So let's try to use the same content and dependence that they are using in their package.json. So let's use these libraries and import correctly. Okay, so let's start to import our libraries. We're gonna use okay. I'm using the out the I'm using the Copilot from GitHub, so you can autocomplete. I also gonna import the access control. I'm not sure that we have here. No, not access. I would need to using the access control. Access control. Okay, nice. Also, we need to use our the burnable smart contract. So the open Zeppelin. Not this. I will just use the token ERC. Okay, ERC burnable and houseable. Yeah, yeah, that's okay. I'm not sure that I want to use. Okay, okay, let's use the houseable from the ERC. Oh, it's not. Sorry, guys, not the. It's not this whole location. It's in security, and okay, now it's fine. All right, guys. So our contract, I will just extend to ERC20, the ERC20 word naval access control and pausable. All right. Okay. Cool. 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 So as they are using the access control. Whoa, whoa, whoa. Something interesting here. Okay, let's see what they are doing. It's help a lot. But we also need to add a few new uh, functions like, yeah, yeah. The pause role. That you need the pause role because, as I show you guys, they are using a few roles provided from that ABI. So we need to work with the default admin role, minter, move, and pause. So let's do it using our smart contract as well. Okay, so let's create a new lines here. Burn and roll. Yeah, yeah, that's a good one. The freezer roll. Let's use the same roll that I used. So it will be the pause roll, and pause roll. Okay, and the mover roll, mover roll. Cool, cool. So we have also to create, let's say, we also need to delegate this role using this command here. So move, mint, um, okay. Yeah, yeah, yeah. That's one, two, three, four, five. Yeah, I think is, is there something that I'm missing here? I'm not sure, but I think that's it. And yeah, I don't want to start this contract meeting right now. So we have these three functions here. Let's work on this constructor now. What we'll pass here, just uh, maybe I would do something like this. Name. Maybe I can also use symbol here. But I will expect a construct with three arguments. The first one is name, the second one is symbol, and I will create a new one to be an address to be called as authority. Okay, cool, cool. So, by default, as you can imagine, by default, if wallet address to central bank, they need to be, they need to have the standard behavior to delegate automatically address using the deploy. So we need just create, instead to use message sender here, I will just use the authority here. Because doing this, not necessarily who is deploying the smart contract should be the owner. So others companies, others institution can also uh, deploy this smart contract, but uh, we will pass the address to be authority using the script in making isolate function. So okay, we have this stop and rows here. I think our construction, it's kind of finished. It's kind of done. So let's keep focus with that frozen um that polemic function called frozen, increase frozen balance and decrease frozen balance. So will be this one. The function increases balance is expecting two args like the from and not. So let's do it. So let's recreate our function. Function increase balance. Okay, it's expected. Okay, let's do it just for now. From, so it would be the from address. So it would be the throw address, and also we need to change here to be okay. That's fine almost. So who can let's remove this. Uh, we don't need to have this right now. So let's go ahead and create a require here. So require has role to move. So in this case, we're gonna set up to just who have the mover role can move the phones. Otherwise, we have a error message like the color is not a move, right? That's okay. So if increase fraud balance has attempt to require, we gonna not mint. We should make um they are working with authorized accounts, as you can see here. Authorized accounts. Okay, so we have this authorized accounts, as you can see. Let me find this. Okay, we cannot see in the generate interface, but we can see here that we have this authorized generate icons. So basically, the main function of this authorized icons is just a mapping of both. So, as the central bank built this smart contract, we need to also add this mapping of address, of course. Uh, no, that's not frozen balance. Let's do it bool. So it's a private mapping of authorized action, but we can also use the frozen map. We can just write here the mapping freezing balance. All right, all right. Okay, we need to use these two maps here because after to increase the frozen balance, um we also need to add um frozen balance. Okay, the amount of the amounts of the frozen balance here. We also need to add the decrease frozen balance. So instead to add, we need to make this operation. All right. It's so. We are using this map here, and let's add also a function to enable function, enable account. Okay, well, Git Copilot, it's helping a lot. Yeah, that makes sense. Because as you can see, guys, I was checking, getting this information from this API provider. So it's enable account is expecting one parameter as a member. So instead to be account, let's write the um, member. Okay, and disable as well, and decrease frozen balance is also here. Uh, let's say, okay, from enamels, and yeah. So another one is to disable. Okay, yeah, that's okay. All right. Yeah. But instead to use the movie role, just just the central bank can uh, enable disable icons. So in this case, it will be the default admin role, right? And yeah, yeah. So I think it will be enough for now. Let's check if com our project is compiling. So your hard hat compile just to make sure that we have some syntax error. Oh yeah, we have one. Um, okay, we don't have installed this um library here, so let's do it. Yeah, so let's do it again. Oh, imports is outside mode. Oh, okay, guys. The issue is not exactly this. The issue is because the original file is in TypeScript and yeah, I'm using JavaScript. So just let me copy this part right here and keep it the original file. Yeah, that would be easy in pass here. So let's adapt it for Y. And let's try again to compile. Okay, we have some plugin issues here. Um, yeah, have some issue related to the fact there is a TypeScript. So um, let's move on and try to add this library that is requesting here. Verify and the type chain. Okay, yeah, let's go ahead. Okay, cool. Let's try again. Let's see if your smart contract is compiling. Yeah, so we have some issue related to the fact that I'm importing in the line 7 from this file. Let's see. Okay, it's missing something here. Yeah, okay. Yeah, let's go back and try again. The access control have double F. Yeah, yeah, we just won. That's right, yeah. I'm sorry, guys. This is a mistake we used to do every day, so let's try again. Okay, we have an icon without being declared. Yeah, that makes sense. So let's go back and try to we need to create this icon variable. Let's see what we can do. Yeah, the issue is that I renamed it to member, but I didn't remove, I didn't rename the member, the icon to remember here. So yeah, that's why. Let's try again. Oh, we have another issue here. Yeah, because we are declaring two times the file role. Let's see. Yeah, we also have two roles with the same extension. Uh, yeah. So yeah, finally, that's it. Yeah. So it's just some issues about to we need to update, of course, because it's a regenerated smart contract. But yeah. So I think we have the most important function here. Cool. So let's move on. Let me write here function transfer requirements would be the address, recipient, unit, amount. Okay, cool. So, it's a public of the right. And also, um, yeah, let's do it for a while. But as you can see, we have some different override function. Let's think, let's find, yeah, here. It's non-payable. It's a rule. Cool, cool. Transfer from. All right. So basically, we need to add a few requires here. Well, that makes sense. Just authorize it. Can authorize a function can transfer. All right. And yeah, and also require the frozen balance is more than the amount. Yeah, yeah, that makes sense. Let's keep this for now. We also have the transfer at the end and the frozen balance. Yeah, yeah, yeah. Let's skip this. And also we need to add the transfer from, and this transfer from have the, let's see how they name it, the parameters. So will be the from address to and amounts. Okay, so it was correctly. Yeah, and transfer from should be has the address, then the address, and the unit you enter to see 256. Oh, yeah. Mm-hmm. Yeah. So it's a public override and returns a bool. Yeah. So this makes sense. Cool. Yeah. So let's make a required statement. Okay. Yeah, we have this. And yeah, it's pretty much the same. It's like it's very have the same feature, but remember that we're working with override because why we need to repeat this function that we got from the ERC standard? Because as you can see, we have this pause function here. So let's add a function here to when not paused. Where is this? This is a type of function that we got from the pause smart contract, right? The security posed smart contract. And the main idea of this is to not be able to transfer when the smart contract is paused, because this is one of behavior that we expect from this smart contract because they are using this. And yeah. So the main idea is to have this behavior. All right, guys, cool. I think we have enough function implement by uh, the ABI provider. We can also have a lot of we can do a lot of test case here to make sure that our smart contract is working as expected. So yeah. So let me check if we have another thing here. All right, so let's move to another. All right, guys, so that's enough to now. What's up, guys? So let's continue to our smart contract demonstration, some user case and challenges to be associated with these functionalities. First of all, if you never see this unit test before, let me explain you. Using this unit test, we can make sure that our contract is expecting is exactly what we are expecting. So all these functionalities, all this enable out, disable out, and function that we wrote in the last video, we can also uh, make sure that this smart contract is working as we expect. So first of all, we need to create this structure like this one, like describe in real digital, and this before each. So basically, in the before each, we just set up in the unit test to load our real digital smart contract and also deploy into a private blockchain in our case we are going to use the hard hat blockchain. So basically we just create a few variables such as the admin, the mint and burning. Also we are deploying, so we just make to sure that your real digital is deployed. And also we are creating and delegating these roles, I mean, um, to this smart contract using the minting and burn address. So basically, we are using this contract to grant a role. I mean, we are uh, set up in this smart contract to set the correctly role, like such as the minting role, the burning role. And yeah, so before each describe scenarios, we are set up in our smart contract. And now, yeah. So basically, in this test case, we're just making sure that we have correctly set up our admin privilege. So we are just associating this variable to default admin role. And also Boolean, we are also respecting to Boolean result from this function right here. So we just make sure that our smart control has the correct privilege as a domain role. And then we also are making sure that we set correctly the burning and minter privilege, because as you can say, guys, as I said, uh, who has the privilege to burn it in minting new contract uh, using the API provided from the the central bank is set up here. So they are using the access control. That's the reason we are, set up in this role here. In your case, in our test case, we just make sure that we have it correctly set up. And yeah. So, uh, just skipping for the next part of this unit test scenarios, we are meeting in this meeting test. We need to make sure that we can meet need tokens, uh, and that's why we are connecting using this variable here. Like remember, guys, when you use the let um, variable, as you can see here, is different that we use like const, right? Because we are set up in here that let the variable let can be changing every time we run it. So if you will use like constant, like we use here, we cannot associate with name variables. So that's why you need to work with let. And that's why we can also use the real digital here and then connecting. Remember also that real digital is our the instant of our smart contract. So We are connecting to the instant of our smart contract using the mint and burn address. Sorry, not address, but or the object to from the mint and burning. Remember the mint and burning is the second address provided by get signature. So the get signature, the first one, the first value of the array use the admin of the smart contract. And yeah, so we have the second variable that we will call it as a mint and burn, the address one. All right, just yeah, so we are connecting to the instant of the smart contract using our mint and burn. And then we are meeting again, but we are meeting for the address from the meter and burning. So, and we are also meeting this value of 100 ethers. So basically, what you're doing is we are connecting to the contract as the meter and the meter and burn address, and then we are meeting. Yeah, exactly. We're meeting 100 tokens to the minted bond address. So it's just to, it's more the same, but this is exactly what we usually to do for unit tests. We set it up and make sure that the smart contract that had exactly behavior as we expect. So we expect the balance to be equal to 100 ethers. So we're expecting the real digital, the balance from the meet and burn address have the same uh, 100 ethers. So it's like it's more the same, but we're just expecting this to be correctly maintained. And then we also have the burning. As you can see, we are maintaining 100 ethers, and then we also burn the half part of this 100, so 50 ethers, and then we make sure that the balance is 15. So it's pretty much the same for meeting, but we are burning. So we are taking away this meeting from this address and just make sure that the balance after be burned is the 15 veil. And yeah, so just to get continued, we also have this unit test to the account managing. So the account manager, as you can see in this smart contract, is the privilege to disable and enable accounts. So the Central Bank of Brazil have created this smart contract to, and they know that they need to have the privilege to disable account, enable account as they wish. That's another thing. There's another polemic topic. So, uh, I'm not agree. I think disabled account, enable account should be, should be assessed in this smart contract. But we need to make sure that the central bank has the correctly uh, set up a privilege and why someone should be disabled, why someone should enable. So I don't know. I think we have. That's why we need to ask our central bank to open the source from the smart contract because there should be a reasons for each central bank disable and enable account. But for our case, we just no, we are just accepting the fact that the central bank can do it. And well, as you can see, guys, every time the central bank disable and enable account, they also create an event, and the event here is set up in the line in 19, but the event in the solidity is a very good way to intercept uh, the event. The events are a very good way to intercept these actions because we need to sometimes in the back end or in the front end we are waiting for some event. For example, when we create a synchronized events, for example, we can set up in the front end in the front end part to increase frozen balance, but our front end is also waiting for any response from the smart contract. So that's why we need to set up this type of event here. So in this case, every time the central bank is enable and disable account, we also gonna create this event. We also can intercept on our backend on our front end. So back to our test case, we need to make sure that the smart contract can connect as admin and enable account and also authorize account. So it's pretty much the same. We are connecting enable account and we also so this authorized account, it's a way to get a response from our smart contract if some account is authorized or not. Authorized account is a very simple function to return if account is enabled, is authorized or not. So in your test case, we are connecting an enabled account and make sure that the authorized account is returning true. And then we also make sure that when we disable account, we also expecting the authorized account to be a false. So we just make sure that we can disable account with successfully. And yeah, so this is the same behavior from the enable an account. We are disabled, we are creating authorized, we are disabled account, we are expecting authorized account to return false, and we also connecting and enable and return to be the expecting the authorized account function to return true. So it's basically the same. It's just the behavior that we're expecting from the smart contract, and that's why use is important to make unit tests. So it's just to make sure that they have the behavior as expected. Well, that's another polemic topic. So frozen balancing. Uh, frozen balancing, it's a way to the central bank set up how much the balancing from a specific account can be frozen. In this case, we are connecting as a GME. It means we are connecting as a central bank, and we are increasing the frozen balance to 50 ethers. So just remember, guys, it's not ethers. It's the ethers is a format unity, but in this central bank case, it is not will not will be ether. Will be 15 reais, right? Because the currency from the Brazil is reais. That's why it's real digital. So we in this case we are increasingly frozen. We are also checking how much balance frozen balance we have in this address, right? Can you guys you understand what we're doing now? So it's just increasing the and make sure that the balance frozen is actually 50, and also the same here. We are just create decreasing the frozen balance, connect as central bank and increase the frozen balance for more 50 reais, and then connect again and decrease. So it's pretty much the same, right? And yeah, then we also have the transfer. The transfer is standard behavior from the ERC20 tokens, but there's one point. So if the account is disabled, it means that for some reason the Central Bank of Brazil want to disable an account. He can do it, connect as a central bank wallet address and disable, as you can see here. And then we also attempt to transfer. So we try to connect as normal user and try to transfer for another user. So imagine a scenario that the central bank disable in your account. So what are you expecting to as they do it? So your expectation is that you should not be able to transfer. So That's exactly what you're doing here. So if you try to transfer and your account is disabled, we are expecting this function to return send account is disabled. Why? Because of course, guys, we set up here at this line. Let's see. Yeah. So we set up here. So if the account is not authorized to transfer, then we will return false and the sender and also return the message. Sender account is disabled, so you cannot transfer. Don't try. They do not you not can you cannot transfer. So that's why they have the expectation here. All right. So pretty much the same. We have this rejected transfer amount exceeds the available balance. Remember, guys, because for some reason the central bank can froze a part of your balance. For some reason, you have 100 reais, and in this case, the central bank just choose to frozen half of your total available amount, so it will be 50. So we need to make sure that part of your balance is frozen and other part is available to be used, right? So in this case, we are mating to the address from the this wallet, and we are meeting 100 reais. And then we are connecting as a central bank, and we are increase the frozen balance to 75. So they are freezing your balance at all. But we just you have you know, you just have a small part of this balance variable. So when you try to transfer uh, 15 reais. What is the expectation? What do we expect as a smart contract is to return false and say, okay, man, you cannot transfer multi-seed the variable balances because the central bank froze your balance, see, and you just have 25 reais of variable. So that's why you cannot transfer 50. And then we also have to make sure that we can transfer tokens if we try to transfer not enough more than we have variables. So for some reason, the central bank enable in your account also and then try to mint when 100 reais. So we are minting 100 reais for your address, and then the central bank say, okay, let's increase the frozen balance to 50. So you just have half of this value, the initial value of variable. So you have 50 reais available to transfer. So if you try to transfer um 20 reais, so you should be able to do it. And yeah, so if you try to do it, we also need to make sure that the 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 balance available from the this smart contract here it also be 20. So it's pretty much the same as we can do it here, but this the difference that we are transfer enough variable amount. So we expecting to successfully transfer, but we also still being with the balance frozen. So that's it, guys. This is our unit test that we are expecting. Now let's try. Let's say that let's try to run our test case to make sure that all this behavior is working as expected. Yeah. Good. So what it means, all this checklist here, it means that the smart contract pass all these real case scenarios. So this smart contract is working and have the correctly behaved as we expect, even we are reverse engineer using the API, all smart contract makes sense. So that's why this the main reason we recreated it. Of course, maybe, of course, they will provide a different smart contract. Maybe they change a few roles or few lines, but it will be very, very, very similar than this smart contract and have the correctly functions name and returning types also how we respect. So we can use this real digital as a sample, right? So that's it, guys. That is a few scenarios that the central bank can froze, can mint, can enable and disable a few accounts. Remember that the real digital have a different financial structure because, of course, this is specific from Brazil and different central bank that have the different financial structure. But we have a main idea how the CBDC can work. So thank you, and let's see in the next video. All right. Let's get back. Central Bank Digital Currency, commonly refers to CBDC, are a novel form of digital currency that are issued and overseen by country's central bank. Unlike the traditional currency, CBDC have the status of legal tender, meaning that they are recognized by government authorities as an accepted medium of payment. Beauty on blockchain technology, CBC brings forward to the benefits of transparency and security in transaction. CBDC aren't cryptocurrency, but they need to use cryptographic. Decentralized finance, known as DeFi, is an emerging and fast-growing sector within the blockchain industry. DeFi employs smart contracts, primarily on the Ethereum blockchain, to emulate conventional financial systems such as loan, insurance, and more, all in a decentralized manner, which is eliminate the need for intermediary. Basically, DeFi are protocols that is running on a decentralized network. So you can trade and create complex transactions using a P2P network. CBDC and DeFi protocols share a common ground with the reliance on blockchain technology. One of the key areas we are exploring in this discussion is the integration of CBDC into the DeFi ecosystem. Investigate the potential advances that come with this fusion. Incorporating CBDC into DeFi could offer numerous benefits. Incorporating CBDC into DeFi could offer numerous benefits, including a high net, transparent, and efficient. This due is the inherent qualities of blockchain, the foundation for both CBDC and DeFi protocol. So, can you imagine to make a very complex transaction between two countries that they doesn't have common laws? For example, imagine that you are living in USA and you'd like to make a transaction in Brazil, but you don't know how the law in Brazil works. You can trust in DeFi protocols because it's all about algorithm. So it could be beneficial for both. However, this fusion of CBDC and DeFi is not without its challenge. Striking a balance between the decentralized ethos of DeFi and the regulatory requirements of CBDC is a challenging task, which we will explore further in this discussion. A critical aspect to consider in the rise of CBDC is a concern voiced by the cryptocurrency community. These include the potential governmental control over personal finance, the possibility of surveillance, and the erosion of the centralized ethos that underpins cryptocurrency. CBDCs are a significant step forward in the finance innovation. While the increased traceability of CBDC can offer benefits, it also raises concern about user privacy. How central bank manage these issues? Strike a balance between regulatory requirement, transparency, and privacy. It would be critical for the acceptance of success of CBDC. As a venture into the role of CBDC, it's crucial to understand the importance of regulatory consideration. Legislation such as the cryptocurrency law sets a guidelines for virtual asset operation. Similar consideration will be vital in the development and implementation of CBDC or the right. As a notable aspect of CBDC project involves smart contract. However, for the effective use, it's crucial to ensure the public's exposure of the specifics. Doing so promotes understand, trust, and foster participation in digital finance landscape. All right, I hope you like this tutorial. First of all, we analyze the CBDC source code function and also make sure that our smart contract is working as expected during a unit test. And also examining the CBDC and DeFi protocol, addressing concerns and benefits. And at the end, we see the regulatory and public exposure. So thank you to watch this tutorial and see in the next one.